Today's lesson, we're going to learn about modeling trajectory with quadratic functions. As I type, I expect you guys to fill in the guided notes, and that is what you're going to work in today, is your guided notes. So, trajectory is just motion, right? It's just launching and moving objects, right? What are roots? Roots are the x-intercepts of a quadratic function. Sometimes we call it the solutions to a quadratic function. Vertex is the turning point, right? This is the y value of the turning point of the vertex, called the maximum when a is negative, and a is the number in front of the x squared. All right, so just make sure that you have these written down in your guide notes, and we'll get started with our first problem. So a shot put thrown can be modeled using the equation y equals negative 0.0241 x squared plus x plus 5.5, where x is the distance traveled in feet and y is the height. How long was the throw? Okay. So what does x represent? The length of the throw, right? And then what does y represent? The height of the throw, right? So are we finding the roots, the y-intercept, or the vertex? We want to know the length, right? So we want to know, like here's the shot put. We want to know when it hits the ground, right? Because that's the length of the throw. That's how long the throw was. All right. So we need to find the roots because we need to find the length, which is x. Right? So if we needed to find out the y, we would have to find what? The vertex, right? Or specifically the maximum. But here, they just want to know, how long would, not how long, but for, how far did they throw it? What was the length of the throw, right? Which is just here, right? How shot put works is you win by throwing it the farthest, not the highest. So so we're looking at the x-axis. Sometimes it's good to draw yourself a little picture like this so you know. So we go to Desmos. You go to start graphing. And we put in our thing, right? So negative 0.0241 x squared plus x plus 5.5. Okay? Now, you might say right away, hey, this is not helping me, right? So you have to, to zoom out. All right, so we zoom out. And we love Desmos because Desmos is a smart calculator. It knows that key features are the things that we care about. And like we said before, we don't really need any other key feature other than the root, which is 46.411. All right. So why don't we care about? So we got that root, but why did Mr. Pillisher care about the negative root? Because it's a real world problem, right? So real world problems, the person who threw it at 5.5 feet, right, threw it at 0 at the origin, and it was in the air, traveling along until it got to 46.411 feet? Yeah, feet. So that's it. So our answer is 46.11, 0.4111 feet, which remember in our class, oh, my statistics class, so we're going to put that as our answer for number 1. All right, so what are the steps? You identify what x is in the problem. You identify what y is in the problem, right? And then you ask yourself, which key feature are you looking for? Roots, y-intercept, or the vertex? And then you find it using your graphing calculator. Let's do the next one. A ball is launched upward at 48 feet per second from a platform that is 100 feet high. Find the maximum height the ball reaches and how long it will take to get there. Okay, so h is y, right? So h is the height of the ball in feet. And x is seconds. That's x is time in seconds, right? So they want to find out how the maximum height, right away, right? We know that's the vertex. And how long it'll take to get there, which is the x value of the vertex. So this is a vertex problem, okay? So we go back to Desmos, right? Mr. Pilcher's lazy, so he's just going to erase the numbers, but not the variables. Right? I recopied my equation. My equation's big, right? So I have to zoom out. Not a big deal, not with Desmos. Remember, we just really needed the vertex, so just get close here and click on it. So at 1.5 seconds, the ball, wow, reached 136 feet. Okay, that's how you read these things. The x value is the time, and it's at 1.5 seconds. It reaches its maximum, which is 136. So you write at, oh, I didn't write it down. 1.5, comma, 136. At 1.5 seconds, the ball reaches 136 feet. Good. So now we go on to example 3. An object is launched at 19.6 meters per second from 58.8 meter tall platform. The equation of the object S, okay, at time t after the launch is S of t equals negative 4.9 t squared plus 19.6 t plus 58.8. If you noticed A is always negative in all these, it's because of gravity. So like gravity pulls things down, right? So if anything's being projected, right, that it's going to have a negative action going down. So where S is in meters, all right, so that's our first. Notice that I took away the question, so you have to remember. So X is time, and Y is height in meters. All right. When does the object strike the ground? When? So when is time. So they want to know X, right? Now, when it hits the ground, right? Well, the height would be 0, and the time would be x, right? So we're talking about the roots. So this is a roots question. So we're finding the roots. All right. So we go back. We change it to our equation. All right. And now we go back down. We just look at the roots. We go here and here. Negative, right? So we're not going to do it. So we ignore the negative. It's in the air for about 6 seconds, right? It was launched, like they said, at 58.8 meters, right? So we go back here and say the air for 6 seconds. All right. So for today, you just have to fill out this guided notes, and then you just have to do that one question as an exit ticket, and that's gonna set me up. You just have to hand in the exit ticket. You don't have to get it correct. So today, to get credit, it's just completing these activities. It's not actually, you don't have any problem sets you have to worry about. That'll be tomorrow and Wednesday. All right. Hope all is well.